Hi guys, and welcome back to lesson 5 of consuming energy resources. In today's lesson, we're going to be looking at unconventional sources of oil. Now, what we mean by that is we don't just drill a hole in the classic way and pump it out of a pipe. No, we have to actually go about a few more processes and some quite damaging processes for the environment in order to extract that valuable resource that we want. So the two types of energy extraction that we're looking at today both apply to oil and gas. Often, of course, oil and gas are found together, so particularly fracking applies to oil and gas. Tar sands, on the other hand, is a much thicker and heavier hydrocarbon, and so we're going to get mainly oil out of tar sands. Okay, so let's get started. So before we start talking about our unconventional sources of oil and gas, our sort of slightly weird ones, we actually have to talk about why we interested them in the first place, because these more complicated methods of retrieving oil and gas from the Earth's crust is not motivated by just the demand for energy, but it's also motivated by a mixture of political factors. And really, the political motivation behind this is about energy security. So we're going to start off by thinking about what do we really mean by energy security. When I talk about security in the context of geography or geopolitical influence, as we are today, we mean not security in the sense of being safe necessarily, but security as in, do you feel secure, as in, can you rely on something? So if I said to you, do you feel safe and secure? The idea would be, okay, well, I've got a roof over my head, I've got food in the fridge, I'm not worried about the future. So for a whole country, when we talk about security, we might be talking about like anti-terrorism in some instances, but we're also talking about having a reliable supply of the essential things. Food security was an issue during the Second World War, and that's one of the reasons that the country started to ration foods, because they needed to make sure that everybody would have enough food. And to do that, they had to control it. So what they were doing there is to try and ensure that they had food security. They not only made deals with different countries, including the United States, to import lots of goods, started growing their own food to make sure they had a secure supply, but they also limited the amount that people had. So this is a slightly different definition of security to the defensive security idea. Now, please do feel free to watch this video. We're going to watch the first half of it, but if you want to finish it off, it is, of course, in the PowerPoint.
Supplies from the East are severed, leaving half of the continent shivering. This gas crisis exposed Europe's dependency on energy imports, which at present includes over 60% of its gas. Dwindling energy resources and increased demand mean that the EU's energy dependency is set to get worse, with gas imports rising to 70 to 80% by 2030. Such massive energy imports will cost an additional €700 a year per EU citizen. As the gas crisis showed, energy dependency can be a major risk and lead to severe economic damage for those hit by supply cuts. Europe therefore needs to diversify its suppliers and supply routes to avoid being dependent on a single exporter. Above all, to improve its energy security, Europe needs to develop a well-functioning EU internal energy market. At present, energy flows often stop at member state borders because of lack of interconnected infrastructures, leading to inefficient supply and wasted resources. The solution? Greater interconnectivity and flexibility of the national gas and electricity grids. This will allow permanent exchange of energy and additional security of supply for all EU member states. Energy diversification also depends on developing new supply routes and interconnections. The EU supports major new gas and electricity infrastructure projects to link Europe to North Africa and gas-rich countries of the Caspian and Middle East regions through strategic initiatives such as the Nabucco pipeline.
Okay, so what we've got here then is this idea that Europe has kind of got all its eggs in one basket. They get most of their energy from importing fossil fuels. Now, that's not to say that we don't have lots of wind farms and solar panels, and we're not trying to go down the alternative energy routes, the sort of sustainable energy routes. But actually, most of our energy does still come from these imported goods, and that includes coal, oil, and gas. Now, gas is one of the worst ones because huge amounts of it is imported. And this leads us to a point where we're saying we are either over-reliant or dependent on imports of energy. What do we mean when we say that? Well, what we're saying there is that we need the imports and we have no other separate source of energy that we can fall back on. So if the people who sell us our energy, and in particular today we're going to look at Russia, but it's not just Russia, if we think about the people that sell us our energy, whether it's the Middle East or the USA or Russia, if they decided not to sell us energy anymore, not to sell us those fuels, what would we do? What would be our alternatives? And if you think about this as like almost like a playground kind of situation in which someone is helping you out and then they say, oh, actually, never mind, we're not going to help you out anymore, you're in a real pickle because our whole economy depends on having a reliable energy source. How often do we in the UK have to suffer through blackouts, for instance, where the energy goes down completely? It very, very rarely happens to us, and our entire economy is heavily dependent on it. So what that does is it gives these other countries who we buy our energy from a lot of control over us. It's almost like political blackmail. If you don't do what I say, or if you don't agree with me on this in an international setting, then we won't sell you energy anymore. And it has happened in the past where, our energy partners have kind of used it as a negotiation method to say, if you want to keep getting our oil and gas, you're going to need to agree to these things. So a couple of ways in which the EU can respond to these challenges, do something about it, okay? To start off with, yes, they can look at alternative energy sources. They can also see if they can get their own energy. Is there any energy that's still in Europe that they can get out? And they can increase interconnectivity so that if, say, for instance, Germany has excess energy, they can sell it to France or sell it to the UK. Okay, so this is a bit of a political start to this lesson. Now, we're going to have a look at one particular dependency. So when we say dependence, we mean that they need it. They couldn't survive without it. And if you look at the European Union's imports of energy, the majority of our energy is imported from Russia. They are the largest single source of energy. So if you have a look over here, in these sort of little tables, you can see with coal, Russia tops the list, then Colombia, the States, Australia, South Africa. Then with oil, Russia is at the top of the list, Norway, Libya, Saudi Arabia, Iran, and Kazakhstan. So, you've got your Asian countries in there, the North African countries, and so that's what you might expect with oil. But perhaps we're surprised that Russia tops both of these lists. And then natural gas, so this is like our methane that gets used in your boiler or in your cooker or in the Bunsen burners in school. Again, topped the list by Russia, Norway, Algeria, Qatar, Nigeria. So, although there are other countries involved, the way to avoid being overly dependent on just Russia is to either encourage energy imports from these other countries or try and move away from coal, oil, and gas. So the EU's energy security, how safe is the supply of energy, is only threatened if pathways from Russia are disrupted. And in particular, if Europe has political disagreements with Russia, how far will they go with that if they know that they need Russia to stay on their side in terms of selling them energy? So in 2010, 74% of the EU's gas imports came from just 3 countries, Russia, Norway, and Algeria. And that is a huge amount of dependence on just 3 countries. And they're people that you kind of want to keep being your friend, keeping them sweet, making sure that you're not, disagreeing with them or upsetting them or angering them in any way, because you need them to continue to supply you energy. And this is maybe a bit of an awkward position to be in for European countries that are generally very wealthy and very powerful. So let's have a look at how a lot of the energy gets to Europe, and you'll see how much of it comes from Russia through this map. So EU imports of Russian gas come through a variety of pipelines. Yeah, so these are basically massive tubes that cross the landscape. And there's a few of them. Now, you'll notice that from Russia, 1, 2, 3 of them pass through Ukraine. And Ukraine is a country which struggles because of this. Now, on one hand, it's a good thing for Ukraine because Russia pays Ukraine to have the pipelines go through it. But when Russia started to invade the border areas of Ukraine, in particular an area called Crimea, Europe, who was supposed to defend Ukraine, kind of said, oh, we'll look the other way. Because Russia turned around and said, hold up, if you're going to object to me taking over a bit of the borderlands, then maybe your energy supply won't come this winter. Maybe you won't have enough gas to heat people's homes. So that kind of threat, even though it's quite subtle, has had a huge political impact on Ukraine. Okay, and they are pretty much the biggest route through which Russian oil is flowing. There are other ways though. There's a route that comes down through the Black Sea, through Bulgaria, and up through Austria, which is called, actually I don't know what that line is called, I can't remember, I'm afraid. I think this one, yeah. And then there's this one up here, which we're going to look at in a bit more detail, which is called the Nord Stream, which literally is the North Stream, but Nord is I don't know if that's a Swedish word, perhaps, for north. And that's actually one of the biggest pipelines. Now, it works better in the summer when the sea is not quite so cold, but it is a huge connection that goes directly from Russia to Germany. And Germany, as I hope you already know, is the most industrial country in Europe. They still have a huge manufacturing base, unlike many other countries. And if you look at these colours, I don't know if you spotted the colours before, but it is a kind of choropleth map. So up here, what you can see is how much of their consumption of natural gas comes from Russia. And you can see that Finland and Sweden and Estonia, Latvia and Lithuania are 100% dependent on Russian natural gas. And in some way that makes them a bit vulnerable to Russia, because whatever Russia says, well, they need the gas, whatever they're going to do. Germany is less dependent than others, places in sort of Eastern Europe, but still pretty heavily dependent. Somewhere like the UK, on the other hand, is turning around and saying, no, actually, we have very, very little dependency on Russian gas. So we're going to watch this news clip and we're going to look at this cartoon. And your second task is to explain a bit about what the cartoon is saying about Europe's relationship with Russia. Okay, just a reminder before we go any further, if you haven't answered the 3 questions from task 1 on your worksheet, which looks like this. Come on, worksheet load. There we go. Okay, so you had 3 questions from task 1 from that first video, which I've just explained the answers to. Please make sure you have answered those questions. Okay, then in just a moment, we're going to answer these 2 questions here. So this video is about the Nord Stream, that pipeline that we saw. Oh dear. That pipeline that we saw up here. Okay, that's the Nord Stream. And this video is about that.
The relationship between Germany and the United States has been turbulent since Donald Trump came to power.
I think it's a horrible thing that Germany's doing.
He's attacked Germany's trade surplus, its NATO contributions, and now there's another source of contention.
It's a horrible thing that you have a pipeline coming from Russia. Germany is a captive of Russia.
Under the Baltic Sea, engineers are already laying a pipeline. It'll bring more Russian gas and, some fear, more Russian influence into Europe. There's already a pipeline in place, Nord Stream 1. Nord Stream 2 will run alongside it from Kingisepp in Russia to Greifswald in Germany, doubling its capacity. This is where that pipeline, Russian gas, is due to arrive on European soil. It's still a building site, but it's also become a political battleground. This is the valve that shuts the gas on or off. There's one at the Russian end too. Right now, a lot of Europe's gas is piped in via Ukraine, which Russia pays as a transit country. Ukraine's worried that once Nord Stream 2 is complete, Russia will mothball its pipeline. There's still a lot to do, but they reckon they'll get all of this finished by the end of the year. There is still, though, opposition from within the EU, and America isn't giving up either. They're still threatening sanctions on the Western companies involved in this project.
What we are concerned about is increased influence from Russia at this time.
Isn't the truth that America would like to have that kind of influence by selling liquefied natural gas to Europe?
Look, the fact is that the Americans try to sell everything to everybody all of the time. That's capitalism. That's what we do. But
so why object when Russia just tries to do the same?
Well, let me finish my point. We've been consistently against this project even before we had the ability to sell LNG.
No one knows for sure how much gas Europe will demand in the coming years, but as countries scramble to supply and secure it, its political value is rising.
Okay, so having watched that video, you can see the kind of debate about how much Europe needs Russia and whether or not we want to need Russia so badly. What we've got here is this cartoon in which the Russian president, Vladimir Putin, is, it would seem, playing a pipe. And out of this bag of the Russian gas supply, you've got a kind of snake-like pipe which is hypnotizing this European man in a suit. So the man represents Europe, and the idea is that Europe is hypnotized by Russia's gas supply, and Putin's control over Europe will only increase. So Russia's control over Europe will only increase. Okay. The answer to the second question down here: how much energy does Europe get from Russia? About 40% of its energy comes from Russia, although it is slightly more detailed if you go back to the previous slide. That one. Yeah. So if you need a more detailed answer, there it is. So if we're saying that Europe's reliance on Russia is a problem, then they need to look for some alternative energy sources. In a future lesson, we're going to talk about renewables as alternative energy sources. But how about if Europe had its own sources of natural gas? Well, in fact, it does have its own sources of natural gas, but they're really difficult to reach. They're trapped inside a rock underground, which is called shale. And the shale rock is impermeable. It doesn't allow gases or liquids to pass through it. And so the gas that's trapped in it, in little tiny bubbles throughout this rock, cannot flow through it. It's not like a sponge, or rather it's like a sponge where it's all frozen solid and the gas can't pass between all of the little bubbles. So there's quite a few places in Europe, marked in blue on this map, that have shale gas resources available to them. The question is, do we want to exploit these resources? Do we want to process them and take the gas out or not? And very often the answer has been no, we don't want to take it out. But let's explore this a bit more before we explain why that is the case. Just to be really clear, this shale gas is extracted through a process that we call fracking, but in its long form, we call it hydraulic fracturing. So fracturing means to break. Hydraulic, that word should spark off in your mind something to do with water, okay, just that prefix hydra or hydro. So hydraulic fracturing is to break, in this case, the rock, using high density hot pumped water. We're going to watch a video on this, and there's a set of questions that I want you to answer as we watch this video, okay? Again, they are in your worksheet. Ready? Off we go.
What is hydraulic fracturing, or fracking? Since the Industrial Revolution, our energy consumption has risen unceasingly. The majority of this energy consumption is supplied by fossil fuels like coal or natural gas. Recently, there's been a lot of talk about a controversial method of extracting natural gas, hydraulic fracturing, or fracking. Put simply, fracking describes the recovery of natural gas from deep layers inside the earth. In this method, porous rock is fractured by the use of water, sand, and chemicals in order to release the enclosed natural gas. The technique of fracking has been known since the 1940s. Nonetheless, only in the last 10 years has there been quite a fracking boom, especially in the USA. This is because most conventional natural gas sources in America and on the European continent have been exhausted. Thus, prices for natural gas and other fuels are rising steadily. Significantly more complicated and expensive methods, like fracking, have now become attractive and profitable. In the meantime, fracking has already been used more than 1 million times in the USA alone. Over 60% of all new oil and gas wells are drilled by using fracking. Now, let's take a look at how fracking actually works. First, a shaft is drilled several hundred meters into the earth. From there, a horizontal hole is drilled into the gas-bearing layer of rock. Next, the fracking fluid is pumped into the ground using high-performance pumps. On average, the fluid consists of 8 million liters of water, which amounts to about the daily consumption of 65,000 people, plus several thousand tons of sand and about 200,000 liters of chemicals. The mixture penetrates into the rock layer and produces innumerable tiny cracks. The sand prevents the cracks from closing again. The chemicals perform various tasks. Among other things, they compress the water, kill off bacteria, or dissolve minerals. Next, the majority of the fracking fluid is pumped out again. And now the natural gas can be recovered. As soon as the gas source is exhausted, the drill hole is sealed. As a rule, the fracking fluid is pumped back into deep underground layers and sealed in there. However, fracking is also associated with several considerable risks. The primary risk consists in the contamination of drinking water sources. Fracking not only consumes large quantities of fresh water, but in addition, the water is subsequently contaminated and is highly toxic. The contamination is so severe that the water cannot even be cleaned in a treatment plant. Even though the danger is known and, theoretically, could be managed, in the USA already, sources have been contaminated due to negligence. No one yet knows how the enclosed water will behave in the future, since there have not yet been any long-term studies on the subject. The chemicals used in fracking vary from the hazardous to the extremely toxic and carcinogenic, such as benzol or formic acid. The companies using fracking say nothing about the precise composition of the chemical mixture. But it is known that there are about 700 different chemical agents which can be used in the process. Another risk is the release of greenhouse gases. The natural gas recovered by fracking consists largely of methane, a greenhouse gas which is 25 times more potent than carbon dioxide. Natural gas is less harmful than coal when burned. But nonetheless, the negative effects of fracking on the climate balance are overall greater. Firstly, the fracking process requires a very large consumption of energy. Secondly, the drill holes are quickly exhausted, and it's necessary to drill fracking holes much more frequently than for classical natural gas wells. In addition, about 3% of the recovered gas is lost in the extraction and escapes into the atmosphere. So how is fracking and its expected benefits to be assessed when the advantages are balanced against the disadvantages? When properly employed, this technique offers one way in the short to medium term to meet our demand for lower-cost energy. But the long-term consequences of fracking are unforeseeable, and the risk to our drinking water thus should not be underestimated.
Okay, so having seen that video, we've answered these questions. And if you need to watch it again, please do rewind by about 5 minutes so that you can see that again. Just to go through the answers then, fracking is otherwise known as hydraulic fracturing. And now that you've seen how the process works, you can probably understand that using the mixture of water and sand and chemicals, we're breaking the rock, fracturing the rock in order to release the gases that are trapped inside. And the main reason that this has taken off, and it's been very popular in the United States of America, although it's not yet popular in the UK, is because the conventional sources of oil that are much easier to extract are starting to run out. Fuel prices have been rising, although we did see a video recently to see that the fuel price has dropped dramatically because of coronavirus. But ignoring coronavirus, fuel prices have been going up. And that, because the price of fuel is going up, it makes it more profitable to use a complicated method. When we look at the profit of a company, we're looking at how much it costs them to get it out of the ground versus how much they can sell it for. And if the gap between those two is not big enough, then there isn't much profit. Okay? But the more you can sell your oil for, the more it's okay to spend on getting out of the ground. So although this is a complicated and more expensive way of getting gas out of the ground, if the price of gas is going up, it becomes worth it. So about 60% of new sources of oil and gas are actually drilled using fracking. But it is causing quite a lot of problems. And one of those problems is to do with the amount of water that it uses. 8 million litres of water per well. And as well as the water that's going in, they're contaminating that water with a couple of things. Firstly, they've got sand in there to stop the cracks from closing up again. And then they're adding lots and lots of chemicals, and those chemicals mixed in with the water and the oil are there to kill bacteria, to make the water denser, so to compress it and make it all the particles sit closer together, and to dissolve the minerals and the gases and other things that are going to get in the way. Now, that water gets pumped out before they extract the gas. But once the well is empty and there's no gas to be taken out, they've got loads and loads of contaminated chemically water. And what they tend to do is just pump it back into the ground and try and seal it up. The problem with that is, of course, that you don't know exactly what's going to happen to that water now you've left it inside the ground. And it has in the past, and probably will continue, to contaminate water supplies. And those contaminated supplies cause a whole heap of health problems for people living in the areas where this is happening. So you get much higher cancer rates, which is why we have this word here, carcinogenic. Much higher cancer rates. You get lower life expectancies. You get higher rates of infant mortality, or children being born with physical deformations or mental health issues. And so in addition to that, the process of fracking actually lets quite a lot of methane gas release into the atmosphere. Now, we all know that carbon dioxide is a terrible greenhouse gas, but in fact, methane itself, if you have a gas leak just coming out of the ground, you are actually releasing another greenhouse gas into the atmosphere. And methane is a very, very, very powerful greenhouse gas, 4 times as powerful to trap heat in the atmosphere as carbon dioxide. Now, obviously, there's less methane in the atmosphere generally, which is why we're less often talking about it than carbon dioxide. But that doesn't mean that it isn't an issue. And this is one of the reasons why it's much more harmful to the environment than other types of fossil fuel extraction getting it out of the ground. So about 3% of the natural gas is lost during the fracking process. And ultimately, the point of doing fracking is because we want cheap energy and we want it now. And switching to alternative renewable energies seems to be taking too long. So, on balance of all those risks, many European countries have decided that they don't want to allow fracking. In the UK, however, the decision has not been fully made. Wales and Scotland have decided that they will not allow hydraulic fracking, whereas in England, the government is supporting it, and a lot of people in those local areas who don't want their water supplies contaminated are are objecting to it. So it's still a debate that is going on across the country. In your notes, the 12th question is for you to put your opinion down. I want you to tell me how risky you think fracking is and why you think it is super risky. Do you think it's really risky, or actually do you think, no, it's worth it? We should totally go ahead and do it. Maybe we can control the risks. So let's say, for instance, that we can't do hydraulic fracturing. Where else can we get energy from? Well, one of the places we can get our oil energy from is something called tar sands. Now, again, this is a completely natural source of fossil fuels. It's just an unconventional one. It's not drilling a well and sucking it out, okay, from a reservoir. Instead, it's digging the oil mixed with sand, clay, and water in this dense, sticky mess out of the ground. And unfortunately, this process looks something like this. Now, all the photos I'm about to show you are from Canada, and in particular an area of Canada called Alberta and a set of tar sands called the Athabasca tar sands. Now, in fact, when we looked at the forests unit, Forests Under Threat unit, we also looked at the Athabasca tar sands. So we're using the same case study twice, okay? I recommend strongly that you learn this case study well, okay? But we're using it again because last time we were talking about a huge nature reserve in the taiga forest that was being protected, and one of the threats to the taiga forest in Alberta is this tar sands project, the energy development that gets bitumen or oil out of the ground. Now, the last type of unconventional source we looked at, fracking, mainly gets natural gas out of the ground. This is getting a thick, sticky hydrocarbon called bitumen. And it's very similar to the stuff that we like tarmac the roads with, that sort of sticky, black, goopy stuff. Okay, so bitumen is extracted from tar sands by digging up the ground and injecting hot steam into the ground to help melt the tar or the bitumen so that it can be mixed with a whole heap of chemicals and hot water, and then the sand can be filtered away, and so can the other, like the chemicals and all of the oil as well. So this requires a huge amount of energy and water. So this is a satellite image, and what you can see in this image is a couple of really key things. One, you can see that the surrounding area is heavily forested, and so the environment that we are destroying, and you can see in this, previous photo how absolutely destroyed the environment is. Okay, it's not like digging a mine where you can kind of dig a tunnel under the ground and leave everything on top. No, what they actually do is they rip up all the trees, they rip up all the soil, and then they start digging into the rock, and it's a big open pit of tar sand mining. So you can see the mine over here, you can see the forest that's surrounding some of the region. This pond here, and I tell you it's a pond, it's definitely not a bit of forest, even though it's bright green, is the contaminated water mixed with chemicals that's left over from the process of turning this into oil. Okay, and right down the middle of this satellite image, because there are a couple of clouds, I don't know if you can spot those, there's a couple of clouds that sort of mess with the image a little bit. Right down the middle of this, I don't know if you can spot that, that is the Athabasca River. And that river flows straight through. So the photo was taken somewhere around here, okay? This whole region is the Athabasca oil sands or tar sands. And that river flows this direction into the Wood Buffalo National Park, which is supposed to be a protected forest. Unfortunately, of course, that heavily protected forest is getting water flowing through it that is coming from a heavily contaminated source. So, really, really quite devastating, I would say, in terms of the environmental impacts. Okay, so we've looked now at two unconventional sources of energy. I know I've used this word a lot, unconventional. It means unusual or not normal, okay? And these are tar sands and fracking. What I'd like you to do in your worksheet is to complete this table. Now, I've done you a waggle in the first column. The first column is all about the stuff we did last lesson, conventional extraction of oil and gas, where you drill a well through the bedrock to reach a reservoir of oil and gas, and then you suck it up, and you either build your platform on the land, or in some cases, you build it floating in the sea so that the pipe can reach the seabed. And there are quite a few places in the world where there are reserves, supplies of this type of oil and gas. So the Middle East has quite a lot of this type of oil. Venezuela and Nigeria also have a lot of that conventional classic oil. That process is really quite cheap, and it's especially where the oil is plentiful, where there's loads of it available, it's easy to access. But of course, as we know, the oil spills and leaks can cause huge damage to the ecosystems. I want you to tell me how fracking works in just a sentence or two, where in the world fracking can be conducted, okay, and you might have to do a teensy bit of a Google search for that one. Is the process cheap or expensive to do? And what are the environmental impacts of extracting that? And then the same again for tar sands. Now, I've answered all these questions in today's lesson, but if it takes an extra 5 minutes of Googling just to make sure you've got the right answers, please, please, please do that. So, 10 to 15 minutes on this task, pause the video, off you go. Okay. Our final task for today then, and this is a bit of a political analysis challenge. In today's lesson, I've kind of mixed together the political side of energy supplies. Do we really want to rely on one country, be dependent on one country for our energy supplies, like Russia is the main source of energy for Europe? Or do we want to go for alternatives that are still not very environmentally friendly, okay? And we're talking about the impacts of these things. So this last task, I want you to choose one of these two questions. The first question is either, why have companies invested in extracting oil from difficult environments, like the Athabasca tar sands and fracking? Or your other question could be about thinking in terms of the UK, why might there be an opposition to fracking in a UK national park? Okay, so we have lots of national parks in the UK, and some of these places have been identified as places where we will find natural gas under the ground, and we wouldn't have to import it or buy it from anybody else. Okay, now this cartoon, I think, really clearly explains the kind of combination of this need for energy and what the impacts of that are. So what we've got here is an oil tanker sailing, saying, "What's that sound?" And someone's singing energy independence. And it sounds so attractive. No depending on any other country. Okay? This whole cartoon plays on the idea of a siren. I don't know if you know what a siren is, but in classic Greek literature, a siren was sort of beautiful women that sat on an island and sang and attracted sailors, and they would be unable to resist the call of the sirens. But when the sailors got there, their ships would be wrecked on the rocks and they would basically be eaten because the sirens turn out to be monsters. Okay, so that's a kind of like classical Greek story that you've got there. Here, in this example, you've got the sirens singing about energy independence, your oil-dependent countries thinking, "Oh, it sounds wonderful, how brilliant, let's go over there, let's get energy independence, how wonderful does that sound? Let's get it through shale gas and oil." And an answer is here, it would seem, to our independence. We're cheap and we're plentiful, there's loads of it left, you don't need to worry. And then, of course, there's a huge amount of environmental wreckage that comes with extracting shale gas and oil through fracking. And so they're sort of trying to persuade you that it's all going to be worth it despite the environmental wreckage. So, giving one of these two questions a go, trying to combine that sort of political side of You know, what do people really want to do? Why is it important that we have these things? Okay, and why is it that companies make these decisions in this first question? And in the second question, why is it that people are actually saying, no, we don't want to have fracking in a UK national park? Guys, I hope you found this lesson interesting and you've learnt something today. I will see you next time. Bye-bye.